Hello everybody, this is Deep Jyoti Sahu and I am from E3 section Computer Science branch, roll number 52, and today I am going to present myself on the topic of quantum computing, on the topic classical versus quantum probabilistic systems, which means exploring fundamentals differences through double slit experiment and billiard ball experiment. So here we begins. So first, here are we are going to study here of four content: classical probability, quantum probability, double slit experiment, and billiard ball experiment. In classical probability, we are going to understand the deterministic system and classical probability. In quantum probability, we are going to study of quantum mechanics system and wave function. In double slit experiment, we are going to study the interference pattern, wave particle durability, and in billiard ball example, we are going to study of we are just comparing it and the form of classical deterministic motion with quantum probabilistic behavior. Okay, so here the first topic: classical probabilistic system, deterministic foundation. Classical probability is the thing which describes the systems on the outcomes from the initial conditions. If we don't know them precisely, like if we don't know them precisely, we use this probabilistic system. It has three subtopics: predictable outcomes, probabilistic distributions, and unique trajectories. Predictable gives perfect information futures. State can be calculated precisely using Newton's law. So here we use Newton's law as a subject. Probabilistic distribution: uncertainty arises from incomplete knowledge, not fundamentals randomness. And in third, unique trajectory: each initial condition leads to exactly a deterministic path. So these are the three subtopics of classical probabilistic system. So classical billiard ball system is the first and finest example of all of this. So we are taking an example here: deterministic motion. In classical billiard ball system, the motion of balls completely determines if the motion of the balls has the power to determine the position, velocity, or law of mechanics in every aspects here. Given a perfect, it also gives the perfect measurement, can predict exact future, position, collision outcomes. But at the end, this helps to determine the initial positions, mechanics at every point of the time. And in collision dynamics, each collision follows conservation's law. The angle of incidence equals to angle of reflection. Momentum is conserved. Multiple ball create complex but predictable chain reaction and can be calculated precisely. So this is the example we took here as a classical billiard ball system here. Outcome probabilistic system now. So wave function foundation is the part of quantum probabilistic system, which means quantum systems are described by wave functions. Those squarted magnitude gives probability densities. It has three subtopics: intrinsic uncertainty, interference effect, measurement problem. Intrinsic uncertainty is the randomness is fundamental. Initial condition can lead to difference of outcome. Interference effect is the probabilistic amplitude add and subtract creating of interference pattern. Measurement problem: observation collapse that wave function fundamentally alternating the system. So these are the three subtopics of wave function and foundation. Let's move to the double slit experiment, which is the most interesting part of this video, and this has three paths which we can consider here: particle source, double slits, and detention screen. What is particle source though? Electrons or photons are emitted one at a time outwards with the barrier of two narrow slits. This is the particle source, like they emits the barrier as an electron or photon. What is double slit now? The barrier contains two closely spaced slits that acts as a coherent source of matter here. And what is detention screen? Individual particles are detected but over time build up and an interference pattern. The thing you can see in the screen, like it states as a detention screen. Here we detect the thing of double slit experiment. Okay, So what is double slit result analysis? Okay, we are on the seventh page of the topic. It has four topics: classical expectation, measurement paradox, quantum reality, and which path information. These are the four subtopics. Classical expectations is the particle should grow through one slit or the another, creating two distinct bonds on the screen. While measurement paradox, observation fundamentally changes the outcome. Demonstration, quantum measurement problem. What is quantum reality? Interface pattern emerges even when particles pass through one at a time, indicating wave-like behavior. And which path information? If we measure which slit the particle through it, the interference pattern disappears. The interference particles disappear in this which path information here. Okay. Now, quantum billiards ball through experiment. It have different three types: wave packet evolution, superposition principle, probabilistic outcome, as you can see on the screen. Quantum ball represented as a wave pocket spreading over a time. मतलब it spread over a time. Superposition particle can multiple has multiple paths simultaneously, while probabilistic outcome has final position known as probabilistically. It has multiple potential collision path exist in it simultaneously in wave pocket. Path interference constructively or destructively in superposition, while measurement collapsed to define position in probabilistic outcomes. Here you can see the graph of probabilistic comparison where classical versus quantum features have been shown in the form of bar graphs. Classical certainty, which means perfect knowledge, eliminates uncertainty probability, refers ignorance, not fundamental randomness, while quantum enterprises means quantum uncertainty is fundamental even if perfect knowledge outcome remains probabilistic due to wave in nature. Okay, now it's the 10th part. Anyone who is not shocked by quantum mechanics has not understood it. It is so shocking in quantum mechanics, like we don't even understand what is things around going on. The fundamental insight reminds us the quantum probability challenge our classical institutes. The double slit experiment and quantum billiard examples demonstrate the nature operates on probabilistic principles at the most fundamental level, requiring us to obtain deterministic thinking when describing quantum performance phenomena. Sorry, my bad. It's the caption or the quote has been said by Niels Bohr, and he is one of the scientists who was very good at quantum computing. So this is for today, guys. Thank you for watching the video. If you like it, just like the video and subscribe the channel. Thank you.